Okay, next one. Another square root equation. So, gee, the other one wasn't that bad. Only took me 7 minutes to do the other problem, and I was saying I probably can't do this one in 8 minutes. So, why? It doesn't look that much harder. But let's give it a shot. Okay, so there are two radicals. So the first thing I want to do is rewrite with one radical on each side. And so it's going to be 2x plus 3 equals 2 plus the square root of x plus 2. Then I'm going to square each side. So just like before, more or less. But here it's really important to remember what I said on the previous problem, and I'll say it here. You're squaring each side. You get one square per side. You are not squaring each term. You're squaring each side. So you get one square per side. Now the left side here, that's easy. Square roots and squares, they're inverse operations. They quote-unquote cancel. Over here, as nasty as it looks, we are still going to have to FOIL it. So starting to FOIL it. 2 times 2, 4. 2 times that radical. Well, there's not much you can do other than to say 2 times the radical. That 2 cannot distribute through the square root. That's just wrong. It's actually violating the order of operations because the square root really is an exponent of 1/2. Unless you clear the exponent, you can't multiply. So there's nothing you can really do except write them side by side. Same thing here. Not much you can do except write them side by side. And then we'll be really technically perfect here. I've got the square root of x plus 2, quantity squared. And we'll simplify it on the next one. Now continue to simplify. Those are like terms, so they can be combined by adding their coefficients. So I'm going to have 4 plus 4 square root of x plus 2. Then squares and square roots, they cancel, so I just have x plus 2. And then continue to simplify as much as you can. And so I have 2x plus 3 equals 6 plus 4 square root of x plus 2. So we've done a whole lot of algebra, and there's still a radical. But I have made progress. I started with a problem with 2 square roots. Now I have a problem with 1 square root. And so essentially you're starting over. So we'll quote unquote start over, getting the square root alone. Oh, I forgot that x there. Don't want to forget that x. I forgot that x. So I'll subtract the x from both sides. I'll subtract the 6 from both sides, and so I get x minus 3 equals 4 times the square root of x plus 2. Now you can leave that 4 there. The coefficient on the radical, you can leave that, and it's best just to leave it, but get the other terms to the other side. And now that that radical is alone, I can square both sides again. And again, you get 1 square per side. You are not squaring each term. You're squaring both sides. And so you keep plugging away at it. And so I'm going to remember to FOIL that x minus 3 quantity squared. And over here, yes, it was perfectly fine to leave that 4 there, but you can't ignore the 4. 4 squared is 16, and then squaring the square root, they cancel, x plus 2. But notice it's now 16 times the quantity, x plus 2. The parentheses there are absolutely necessary. Then keep working on it. And yeah, this is a long, long problem. But if you baby step your way through it, you can get through it. Foiling now. So I'm going to get x squared minus 3x plus 9 equals 16x plus 32. Combine like terms. So x squared minus 6x plus 9 equals 16x plus 32. Then you step back and you look to see what you got. And I see that x squared. That's the highest exponent. That makes it a quadratic. Set it equal to 0. And so that's what I'm going to do. Does not matter which side the 0 is on, so I'll just bring everything to the left in this case. And so I get x squared minus 22x minus 23 equals 0. Yep. Then either factor the quadratic formula the way they write textbooks, not the way mathematics happens, but the way they write textbooks. Once you've done this much work, it's probably going to factor. That's just the way they write textbooks. It's not the way mathematics works. The way mathematics works, most things actually don't factor in mathematics. So mathematics work could probably be the quadratic formula. But the way the textbook works, it probably factors. And that does factor to x minus 23, x plus 1 equals 0. And now it's factored and equal to 0, so I can split it up. But that's the only time you can do that step of splitting things up, when it's factored and equal to 0. And so I get x equals 23, x equals negative 1. But we squared both sides, so we must check. You have to check it. Now you can check it by hand like we did the other one, or if you are into using your calculator, you can check it on a calculator. And there I did the checking on a calculator. But like I said, you'd check it by hand just like we did on the other one. And so when we check this one by the calculator, and this does actually show a drawback of checking by the calculator. One of the answers we're checking is 23. So that standard window that seems to work all the time, that standard window that goes from negative 10 to 10, wouldn't work in this case because I had to check an answer of 23. So I put it all in there. And I did a window of negative 2 to 25 because that would take into account my two numbers here. I had values of negative 1 and 23. And so I picked a window that included my numbers. I started at negative 2 because that's going to include the negative 1, and I went up to 25, that included 23. And then I graphed it. There's my x-intercept at x equal 23. So the negative 1 does not check. And the 23 does. And so anytime you square both sides, you have to check your work. It is possible that you will get no answers, 2 answers, 1 answer. It just kind of depends on the problem. You have to check. Okay, that's rational equations. Moving on to our next type of equations. Equations with rational exponents. Recall in math, the word rational essentially means fraction. So a rational exponent is just a fractional exponent. Further recall the relationship between fractional exponents and radicals. X to the m over n is the nth root of x to the n, that n is the index. Now let's write it this way. Then we have x to the m over n. The denominator gives the index of the radical. And I don't know why I wrote this on a different line there. And so that's what we're seeing here. X to the m over n is the nth root of x to the n. Let's zoom in a little bit so we can see it a little bit better. So the little n right there is the index. The denominator gives you the index, and the numerator gives you the power. And you can rewrite it either way. Usually the second way is a little easier for computational purposes, this second way. And then remember a rule of exponents here, exponents to exponents. You multiply the exponents in order to simplify it. So just a little review there of some exponent sort of stuff. Let's zoom back out. And so steps to solving equations with rational exponents. 1, standard step, if it has a fraction, clear the fractions. 2, if necessary, rewrite isolating the term raised to the rational exponent. 3, raise both sides to the reciprocal power. That is, if your equation has an exponent of 3/4, you will raise both sides to the 4/3. If the denominator of the exponent to which you raise both sides is even, an even number, you must include a plus or minus on the constant side. If the denominator of the exponent to which you raise both sides is an even number, you must include a plus or minus on the constant side. Because if the denominator is even, you're really taking an even root of both sides and you need the plus or minus. That back up here, that n is the index. Let's say the index is 2. Square root. Square root, the index is understood to be 2. If I take the square root of both sides, you've got to include a plus or minus. And so anytime this denominator of the exponent you're using is even, you're taking an even root. And when you take an even root of both sides, you have to include a plus or minus. If the denominator is an odd number, you do not need to include the plus or minus. And somehow you just have to remember, when do I include the plus or minus, when do I do not? You just have to think. 4, simplify, using the two things that we talked about, exponents already, simplify. 5, finish solving. 6, check. Not optional, you can get extraneous roots. So the big thing here is going to be trying to remember when to include that plus or minus. So we'll end the video here, and on the next video we'll do the problems.